Okay, so today we're going to talk about rationalizing the denominator. When you rationalize the denominator, you cannot have a radical, which we called surge yesterday, in the denominator. See how we have 5 over radical 2? You can't have that radical 2 in the denominator. So what you have to do is multiply it by itself. And when you multiply the bottom of a fraction by something, you have to do the exact same thing to the top. So when I multiply that, I end up with 5 radical 2 on the top, and then radical 2 times radical 2 is 2. And so I've simplified that. I can't reduce the radical 2 and the 2 because one's inside a radical, one's outside of a radical, okay? And the 5 and the 2 can't be reduced, so that one is done. If I look at the next example, 6 over radical 3, again, I have a radical in the denominator. So I multiply the top and the bottom by radical 3. That gives me 6 radical 3 over 3 because radical 3 times radical 3 is radical 9, which is 3, okay? So I've gotten the radical out of the denominator. Then I need to see if it can be reduced. I can't reduce the radical 3 and the 3, but I can reduce the 6 and the 3. They're both divisible by 3, so that ends up being 2 radical 3 over 1, which is 2 radical 3. In my third example, again, I have a radical 3 in the denominator, so I cannot have a radical in the denominator. So I multiply the top and the bottom by radical 3. That gives me radical 15 over 3. And again, this one can't be simplified because the radical 15 is under the radical and the 3 is not. My fourth example, both of these are radicals, but what I notice about both of these is they are both perfect squares. You can take the square root of 25, it is 5. You can take the square root of 121, it is 11. So I don't have to rationalize it, I just need to simplify it. Okay, let's try a couple more. Okay, let's say we have radical 14 over radical 10. Now, both of these are under a radical, so I could go ahead and reduce it to start out with. Okay, 2 goes into both of those. When I reduce it, it becomes radical 7 over radical 5. But I still have a radical in the denominator, so I have to rationalize it. Multiply it by itself. Whatever I do to the bottom, I have to do to the top. And that gives me radical 35 over 5. I look at radical 35 and I look to see if there's any perfect squares in it. There's not. 7 times 5, 1 times 35, none of those are perfect squares. And I can't reduce something inside a radical as something outside. So that one is done. What if I had radical 8 over radical 2? Again, both of these are under a radical. I could go ahead and simplify here. They're both divisible by 2. So that gives me radical 4 over radical 1. And in this case, these are both perfect squares. So radical 4 is 2, radical 1 is 1. And I'm done with that one, which is equal to 2. Okay, I think I've got 3 more. Let's say I've got 9 radical 7 over 2 radical 3. Okay, I can't do any simplifying with the 9 and the 2 or the 7 and the 3, but I do have to get the radical out of the denominator. So I multiply the top and the bottom by radical 3. That gives me 9 radical 21 over, this is going to be 2 times 3, which is 6. Okay, then I need to see if this can be reduced. The 9 and the 6 are outside the radical. They're both divisible by 3. 3 goes into 9 3 times, so that's 3 radical 21, and 3 goes into 6 twice. And I can't break down 21, so this one is complete. Okay, 10 radical 3 over 2 radical 2. Now in this problem, I could go ahead and reduce the 2 and the 10 because they're outside the radical. So that gives me 5 radical 3 over radical 2. I can't have a radical in the denominator, so I multiply the top and the bottom by radical 2. That gives me 5 radical 6 over 2. And I can't reduce anything here, can't reduce the radical or simplify the radical, so this one is done. Okay, I have one more. Radical 1 over radical 4. Again, a lot of people try to go ahead and rationalize it, but I notice that these are both perfect squares. So the square root of 1 is 1, and the square root of 4 is 2. So stay tuned for my next lesson on adding and subtracting with radicals.